Hello all. Today I am here to present PPT on advanced oxidation processing chemistry. Before getting to the topic, let me introduce myself. My name is K. Sainiklu Verma from ITB and my roll number is 21951A126. Let's get into the topic. The goal of an advanced oxidation process is to remove contaminants from water and wastewater as efficient as possible. The process is often compared to the removal of stains from natural fibers. The more you wash something, the more it appears to get dirty. In water wash treatment, the most common forms of advanced oxidation are biological process in which microorganisms are used to break down organic materials in water. The physical process in which sediment is filtered out of wastewater using advanced filtering techniques. Other forms of advanced filtering water washing advanced filtering techniques. Other forms of advanced oxidation include chemical oxidation, also known as air oxidation, which uses air instead of water as the oxidant in the process, and plasma oxidation, in which a gas or a liquid is used as a reactant instead of a solid reactant. The most common advanced oxidation process is in water wash treatment are biological processes which use microorganisms to oxidize organic materials in water. The most common of these is in contact process, in which microorganisms are exposed to the water whether they will be treating and use that materials as a source of food. The microbes release hydroxyl radicals as a byproduct of their metabolism, which can attack contaminants in water. This is the most common advanced oxidation process because it is the most cost effective and it is also very effective as of removing organic materials such as fiber and pepper from wastewater. Next, chemical principles. I would like to start by discussing the formation of OH, which is the most important part of the reaction in most AOPs. OH is formed from the reaction of a hydrogen peroxide with a transition metals compound. The oxidation of water by hydrogen peroxide produces two peroxide radicals which then react with the transition metals to produce OH. This reaction is often referred to as the Phaeton reaction after the chemist who first discovered it. The mechanism of OH production part 1 highly depends on the sort of AOP technique that is used. For the example, also ozonation, UV H2O2, photocatalytic oxidation and Phaeton's oxidation rely on different mechanisms of OH generation. AOPs are used for removing contaminants from water in water wash. In this section, I will use the Phaeton process to produce OH. Next, chemical oxidation. Ozone is a powerful oxidant and it is the most common type of AOP used in oxidize organic materials in water wash. Ozone is a triatomic molecule with one oxygen atom and three hydroxyl ions, which are positively charged from of the element oxygen. Because of its chemical nature, ozone is a powerful oxidant and is used in variety of industrial processes, such as the bleaching of paper and textiles and the disinfection of swimming pools and air conditioning systems. It is also used in a variety of consumer products such as air purifiers, as an odor eliminator and as a food additive. Ozone O3 is the most common of AOP. Ozone is created by the reaction of oxygen with water molecules. The reaction between O3 and hydroxyl ion leads to the formation of charged form of H2O2. This occurs in charged form because the H plus ions are attached to the oxygen atoms instead of hydroxyl ions. Next, the Phaeton process is one of the most popular and most effective methods of water wash treatment. It is a chemical process that uses hydrogen peroxide on oxidizing agent to cause a reaction. Hydrogen peroxide is a highly reactive compound that is used to destroy organic populations in water wash. It is a common method of water wash wastewater treatment used in many industries. The photocatalytic activity of the material is in part determined by the band gap. The band gap is the difference between the energy of an electron promoted to the top of the valency band and the energy of the electron that is promoted to the bottom of the condensation band. The energy of the electron promoted to the top of the valency band is the highest energy that a conduction band cannot have. Next, advantages. AOPs hold several advantages in the field of water treatment. They can effectively eliminate organic compounds in aqueous phase rather than collecting or transferring pollutants into another phase. Due to the reactivity of OH, it reacts with many aqueous pollutants without discriminating. AOPs are therefore applicable in many, if not all, scenarios where many organic contaminants must be removed at the same time. Some heavy metals can also be removed in form of precipitate MOHX. Since the complete reduction product of OH is H2O, APO theoretically do not introduce any new hazard substances into water. Next, AOPs are not perfect and have several drawbacks. Most prominently, the cost of AOPs is fairly high since a continuous input of expensive chemical reagents is required to maintain the operations of most AOP systems. As a result of their very natural, AOPs requires hydroxyl radicals and other reagents proportional to the quality of contaminants to be removed. It is not cost effective to use solely AOPs to handle a large amount of water wash. Instead of AOPs should be developed in the final stage after primary and secondary treatment have successfully removed a large proportion of contaminants. Ongoing research also been done to combine AOPs with biological treatment to bring the cost down. Some techniques are required to pre-treatment of water wash and acquire reliable performance, which could be potentially cause the technical demanding. For instance, presence of biocarbonate ions can appreciably reduce the concentration of OH. Next, oxidation process have evolved into a professional science which is still in its infancy. Much research is being conducted in the field of advanced oxidation process with much more to be discovered. One thing is certain, the field of advanced oxidation process is only going to continue to grow and flourish. Oxide has been used to modify the structure of TiO2, which allows for greater efficiency in the removal of organic materials such as fats and proteins from water. There has also been some research that suggests the uses of materials other than TiO2 as the active ingredient or in AOPs such as iron phosphate and some inorganic compounds such as manganese oxide. The most common type of modified AOP is the use of activated carbon, which is used to remove color and odor compounds from water. Another common modification is addition of enemies such as proteases to the AOP to facilitate the degradation of organic materials in water. References. These are the references. Let's have a look on this. By this, I'm concluding the topic. Thank you.